All right. Good morning, everyone. This is Heeseung from the University of Texas at Dallas. Today, I'm going to present a paper titled Breaking News and Filter Bubbles. So thanks to our great co-authors, DK, Guanhu, and Don, we executed a large-scale randomized field experiment. So let me start the research background of this study. So we collaborate with the Washington Post, one of the most influential news organizations in the world. So every day, more than millions of people consume these Washington Post news articles. For this platform, the question of which kind of political articles were exposed to whom is not just a technical issue, because it can directly shape public opinion. So if the one's specific political articles becomes very biased, then the role of journalism, providing different side of different angle perspective, can be undermined. So this is the reason why algorithmic fairness and a filter bubble issue especially matters in this context. So we all know about the concept of the filter bubble that describes how algorithms repeatedly expose the user to consume very similar and exactly the same digital content. For example, a specific recommender system or the targeted advertisement can create a filter bubble so that user cannot consume the different perspective digital content. So this is not just an individual level issue. It could be a more broader social and political issue. So our research starts from this question. How can we break this filter bubble? With the collaboration in late 2024, the Washington Post launches Ask the Post AI, a new search experience. This new search experience is totally different compared to traditional keyword-based search engine. So instead of exposing just a list of articles, just a result of the search, this Washington Post Ask the Post AI shows AI-written concise answer with the submitted queries with relevant article sources. So this kind of new search experience can fundamentally change users' engagement and consumption behavior in the Washington Post. So with this consideration, we made three main research questions. The first, we wanted to identify the impact of the GenAI search on users' engagement activities in terms of both click counts as well as the time spent. So specifically, we considered browsing, search, and article consumption patterns. And second, we were curious, the main research question. The second one is how this kind of GenAI search affects article consumption diversity. So both individual and aggregate level. So we leveraged bird topic modeling, and based on Gini coefficient, we calculated this article consumption diversity. And third, we wondered about the mechanism. How and why this GenAI search can change consumption diversity. So we focused on three factors, including article consumption pathways. So from where this kind of increase or decrease consumption diversity come from. And also we consider the popularity and recency, whether the consumed article under the treatment group were relatively older or relatively more popular articles or not. So in a field experiment setting, there are three distinct stages, so including search tab page, search result page, and article consumption page. So once individual access this search tab page and submitted to perform the specific query, and then that individual is randomly assigned to one of two different experimental groups. So test versus control. And the treatment, the GenAI search results, only displayed on this search result page. So more specifically, let's say that the submitted query was, how will climate change impact flight turbulence in the US? The individuals who are in the treatment groups were exposed to treatment, the GenAI-based result, the answer, as well as the RAG-based source articles. Please note that these all search results, the list of traditional results, are exposed to both treatment and control. So the individual in the treatment group additionally exposed to this GenAI search. Then let's focus more on this treatment. So technically, it's based on RAG, the retrieval augmented generation. So once this system receives this kind of submitted query, Then the system retrieved the relevant articles from their database, the Washington Post database. And based on the content of each source article, the GenAI showed this answer, the explanation of these submitted queries. So when we consider this system, we have two different sections in the treatment. First one is retrieved source articles, and the second one is generated answer. So our research period starts from October 1st to November 7, 2024, and around 48,000 individuals who performed query-based direct search at least once were included. So our data set includes randomized field experiment, individual clicks and search stream, as well as this individual article consumption traffic. Our main dependent variables are engagement activities as well as consumption diversity. So we first measure the number of clicks on all pages as a total page, the engagement activity. And we break down this variable into search page click count, article page click count, and browsing page click count. So when we add the value of the search page plus article page plus browsing page, then the value is exactly the same for this total page. So in the same way, we also measure the time spent for each pages. So in the same way, we measure the total time spent and the search page time spent, the article page time spent, and browsing page time spent. And for the measure of consumption diversity, we'll leverage bird topic modeling as well as Gini coefficient. So we calculated both individual level as well as aggregate level consumption diversity. All right, so let's move on to main finding regarding our research question 1. So the impact of GenAI search on user engagement in terms of click counts. So this is the aggregate total page click counts per users. So we found that GenAI search increased total page click count from 7.8 times to 8.4 times on average. So it increases aggregated engagement activities. So now we are doing additional analysis to find out some CLV, the customer lifetime value in terms of the consumption. And let's see how each browsing page and a search page and article page clicks count are changing. So interestingly, we found that the GenAI search reduced browsing page click counts but increases search and article consumption page count. So a kind of substitution. The people, the users, are depending more the direct search, the query-based search, rather just browsing. And after all, they more consumed the articles. So this is empirical evidence of the information seeking efficiency. So GenAI search increased the search efficiency. So with alternative measured time spent, we consistently found similar patterns. So in a total pages time spent, we found that GenAI search tool increases the staying time from 966 seconds to the 1,025 seconds on average. And also, when we focus on each page time spent, similarly, we found that it reduces browsing page staying time, but increases search page and article page staying time. All right, so let's move on our main finding regarding research question 2, the consumption diversity. So we calculated the individual level and aggregate level Gini. So it shows some statistically significant results. So you can see that t-test and a 10,000 times permutation test verified this result. So we can argue that GenAI search increased the consumption diversity. So it breaks filter bubble. And as you can see on the graph, this is the top 20 categories, the category level mean probability by cohort. So as you can see here, majority, the concentration was on politics article. And GenAI search spread this concentration out to this long tail different kind of category article consumption. So to highlight this result, I prepared another graphical visualization. So this is the top 20 category differences. X-axis is the difference in mean probability. Y-axis is top 20 distinct category. So interestingly, we found that GenAI search major transitions from the consumption of politics to music and bands. So this is surprising things. So our next step was to identify the mechanism. What happened? So why and how this kind of things happen? So how political news article consumption could be translated to music and bands things, right? So we conducted some mechanism exploration. For our first mechanism exploration, we focused on article consumption pathways. So we categorized the consumed article in the treatment group into 3 mutually exclusive paths. The first one, the path 1, is the consumed articles from the session without using GenAI search. And second, the path 2 are the consumed articles from the session using GenAI search, but not rec source articles. And the third one is consumed articles from the session using GenAI search, and it is directly the rec source articles. And then we test that each path 1, path 2, path 3 versus control groups consumed articles to measure the consumption diversity. So interestingly, we found that the main effects on increased article consumption diversity come from rec source articles. So path 1 shows no statistically significant effects. Path 2 shows some potential. So you can see that p-value of the t-test is 0.171 and near the threshold. But you can see that aggregate level Gini showed a statistically significant effect. So when we consider the path 2, there is some potential, the evidence for the increased consumption diversity. However, let's focus the path 3. The path 3 was rec source articles. We can clearly see that on this path 3, increased consumption diversity. So I can summarize that by clicking the rec source articles, then the consumption diversity could be significantly increased by clicking that rec source articles. Next, we focused on an article popularity, whether the consumed article from the treatment group were relatively popular or less popular articles. So we operationalized the article popularity as percentile rank based on their consumption count of each article. And we found that the GenAI search leads users to consume relatively less popular articles, especially the path 3. The rec source articles lead users to consume least popular articles. And next, similarly, we focused on this article recency, whether the consumed articles were relatively older ones or new ones. So we operationalized the article recency as the same percentile rank based on their elapsed days since their publication date. And we found that GenAI search leads users to consume relatively older articles. Among them, test path 3. The rec source articles lead users to consume the oldest articles. So I want to summarize our key findings. So first, we identified that the main reason of this increased consumption diversity, it comes from the rec source article. And that rec source article shows the most, at least popular and oldest articles compared to control group. With these results, we suggest the mechanism is based on 2 complementary sections: systemic perspective and cognitive perspective. From a systemic perspective, this GenAI search tool expands users' initial narrow intent. Their initial narrow intent was to understand the impact of climate change on the flight turbulence. They expand this user's initial narrow intent through contextual understanding. So it indicates that when the system receives this kind of query, the climate change, flight turbulence, instead of sticking the specific keyword like climate change or flight turbulence, they retrieve and present relevant but topically, contextually broader source articles. And based on that, they generate these AI answers. So this is a systemic perspective. Next, from a cognitive perspective, user experience unexpected discovery. So users originally wanted to identify the impact of climate change or flight turbulence. However, they found that there are some source articles that companies are reshaping operations to cope with climate change. So it's like an industry and a corporate, some kind of company things. And also, surprisingly, the user can find unexpected discovery of how airline rethink their controls. So users' interest serendipitously expanded through this combination of systemic and cognitive things. So here's the potential mechanism. So honestly, we are exploring a lot of potential mechanisms, not just for this systemic and cognitive. For example, we are doing additional analysis how users' submitted query characteristics are changing over their repeated use of GenAI search. So based on that, based on the different search characteristics, you can find some potential analysis, potential mechanisms. So now, due to the time constraint, I'd like to just summarize our key findings. First, we found that user engagement activities are increased under this GenAI search. So it's evidence of the information-seeking efficiency. And mainly, we found that the GenAI search increased the consumption diversity. So it breaks the filter bubble. And we suggested some potential mechanisms of context-based query broadening and unexpected discovery. I just want to highlight one main scholar implications as well as a practical implication. So our study provides the empirical and theoretical evidence on how GenAI enhances pool-based search function and media consumption with a large-scale randomized field experiment with the Washington Post. And importantly, this study shows a practical filter bubble bursting strategy. So now, Washington Post can practically well manage their algorithmic fairness. So this is the end of the presentation. Thank you.
Thank you. Really interesting study. We have time for a couple of questions.
Yes. So, fascinating study. I was interested in how did you do path 2? In a sense that how did you select the articles for path 2?
Oh, yes. For path 2, yes. So for path 2 is a consumed article from the session using GenAI search, but not rec article. So let's say that users first performed this GenAI search. And after that, they found some source articles. And after clicking one source article, then user can just browsing. User can do some just browsing, or users can just click relevant article from the initial rec source article. So that kind of things is a path 2. Not direct rec source articles, but another browsing or another direct search-based articles.
So I'm not clear how the articles themselves were selected. So what's the difference between those articles and the rag source article?
Oh, so originally, characteristically, how these kind of articles are different. Oh, yeah. So that it depends on the submitted query. So these rag source articles are directly relevant.
I understand rag source articles. Tell me, how did you select the articles?
The results are just regular semantic search, Google search.
Yeah.
You give the same number of articles for
the control groups.
Yeah. Thank you. Yeah. Okay.
So it's very impressive. I have a comment and also maybe suggest for an alternative explanation. So Washington Post is kind of blue and liberal in general. So the comments about the generalizability, sometimes they are purple, not really red. So maybe you can test the generalizability, depends on the search query. So one of the mechanisms probably can express the political ideology, depends on the queries. Because now your example is kind of like the liberal side. So maybe you look at, because you have the data, right? You have the semantic data, and then probably you can explore.
Thank you so much. That great suggestion. So that's exactly we want to do some additional analysis from that perspective. Yeah. Thank you so much for suggesting.
Many more questions, but unfortunately we're out of time, so we'll have to wrap up. Thank you so much.
Thank you.